Now the power of Viterbi is that if I now have, so D1, D2, if I am looking at D3 day, right, and I am asking here again 3 states are there, right, sunny, rainy, cloudy. So this is sunny, cloudy and rainy, right. The beauty is we said that I have to now, if there are 3, this is 3 into 3 parts, another 3 will come, so it will become 27 parts I have to evaluate, okay. But the beauty of Viterbi is if I have already found out up to this point, right, up to this point I have found out the correct answer and I know which path it is. So it has already identified the path. Not only do I know the probability, but I also have found out the best path. So for sunny, the best path is this guy. For cloudy, the best path is this guy. And for rainy, the best path happens to be this guy. Okay. So we have already identified the 3 paths that will give me the maximum probability. Okay. Now all that I have to do is, if I want to see what is the chance that I will be here, right. Ideally, I would have had to go through the entire different paths. I will not do that at all. I will just take 0.1 is the probability here to achieve up to this point. Then sunny to sunny is what, 0.5. So I am going to take this transition 0.5, okay, and therefore here to reach this state, the best probability that I can have coming through this, that means this already means that I am coming from this path, which is always the best to come to sunny, and then this path to sunny, and that will be 0.5 into 0.1. Okay. Similarly, if I want to come here, from here to here, right, it's also very trivial. This is 0.1725, and again you have to see cloudy to sunny. So we know cloudy to sunny is 0.2, or from the cloudy to sunny is 0.2 from the transition matrix. So this will now become this whole preserved 0.1725 0.1725 multiplied by 0.2, the probability of the path itself, 0.2. Okay. And similarly, I can come from here to here, right, and that will be what? That will be, I am assuming that I already have come here and then here, and then I am going to go, this one is 0.35 into 0.55. So that 0.35 into 0.55, whatever that is, multiplied by rainy to sunny. Rainy to sunny is 0.05, right. So it is 0.35 into 0.55 into 0.05. Again, I find the max of all of this. Okay. So to come here became very trivial. Can you see that to come here I did about some amount of multiplies, and then going from this layer to this layer I needed what? Only 3 sets of multiplies, right? 3 sets of multiplies, or the 3 paths with their original numbers I had to multiply, right? Similarly, there will be 3 more numbers that I will have to come, which will be this guy or this guy or this guy. So I will get 3 more numbers to worry about, or I will come here, sorry, I will come here, what am I doing? I will come here or here or here. So you will get only 3 into the 3 multiplies, because there are 3 states, 3, 3, 3 will get multiplied. So 3 squared multiplies only you will get again. Okay. So what happens is, this will exponentially would have increased, and then if I went to one more state, it will become 3 to the power of 4, which will become 81 paths. Okay. I would have had to evaluate 81 paths, but again here it will be only what, the same 9 paths will come. From here, starting from here, what will I do again? I will go either here, or it will come from here, or it will come here 3 multiplies, because I already have the max. Maxes are stored here, right? The max will be stored here, and 3 paths. Similarly, for cloudy, I will get these 3 paths, this one, or this one, or this one, and for rainy, again I will get 3 paths, right? So again, from layer to layer I'll keep getting this 9 multipliers that I'll get. So every time I'll get n squared basically. Okay. So normally in an algorithm like previously what we had to do, if I had n states, S1, S2, S3 all the way up to capital Sn states, and if I had day 1, day 2 all the way up to day capital T days, right, T days, and n states. Okay. If I had to do the Viterbi path evaluation, it will be n into all the way up to n t times, and therefore it will be n raised to the power of t. Okay. But if you do the Viterbi algorithm, at every step you are doing only n squared. Okay. You are adding now, you are not multiplying. This will take n squared 9 operations plus another 9 operations plus another 9 operations and so on, right. So, at every thing n squared operations happen already, because at this point you have already computed and kept, you are not doing going back, you are only going forward, and that requires an additional 9 multiplies, correct. That is all you are worried about. So, therefore, it will be in the Viterbi kind of a framework, it will be n squared plus n squared plus n squared t times. Here it is multiplied. Okay. So, this will become, if I add t times n squared, it will be t times n squared. So, it will be n squared t. So, n squared t versus n by t. So, the computational gain is very huge. Okay. And that is the power of Viterbi. Okay. So, therefore, if for example, it is typical, I mean it is very easy in speech that you will be operating something of the order of 3000 here. Okay. And t can be easily of the order of 500. Okay. So, this means 3000 raised to the power of 500, right, n raised to the power of t, and this is, I mean, humanly not even possible most of the times. Okay. So, I think if you know that t raised to the power of 73 is itself what, the total number of whatever it is, the universe contains only so many atoms or something like that. Okay. Some number like this, 10 raised to the power 73, and already you are talking about 3000 raised to the power 500 or something. Okay. So, there is no way that you can do it. Okay. On the other hand, with the Viterbi, okay, it is 300 into 3000, right, into 500, right. So, what is it? 9 5s are 45 into 10 power 6 8, 10 power 8. Okay. And this is, I mean, for today's computers, these are nothing. I mean, they'll do it quite quickly. Okay. So, no big deal. Okay. So, you can easily find out things like this quite fast. Okay. So, what is it, not even 4.5 billion, right, it is only around that order, right, 0.45 billion or something, right. So, these kind of things are very trivial to do. Okay. So, this is the idea of Viterbi.